Welcome back. This is the fourth question from Edexcel International Advanced Level, May or October 2020 P2 paper. This question is from coordinate geometry in the xy plane. The question states that the points P and Q have the coordinates -11, 6 and -3, 12 respectively. Given that PQ is a diameter of the circle C, find the coordinates of the center of C and radius of the circle. So let us try to draw a circle first and try to understand what we have given. This is a circle and let us draw a line which is a diameter, approximately like this. So they have given PQ is a diameter of the circle C. This is the circle C and this is the diameter. These are the 2 points of the diameter. Let me write down the coordinates they have given here. For P they have given us -11, 6 and for Q they have given us -3, 12. Now they are asking us to find the coordinates of the center of C. So the center will be somewhere at the center of the diameter. So what we are going to do is, let me take a letter over here, O. So O is exactly at the midpoint, the midway of PQ. So for the part A1 question, we have to use the midpoint formula. So the midpoint formula is given as x, y. These are the coordinates of the center. X, y is equal to x1 plus x2 over 2, y1 plus y2 over 2. Now you can take -11 as x1 and 6 as y1, and you can take -3 as x2 and 12 as y2. And then we have to just substitute the values in the formula. So x1 plus x2, that is -11, -3 divided by 2, 6 plus 12 over 2. So solving this, we have -11, -3 gives us -18 over 2, and 6, 12 gives us 18. 6 plus 12 gives us 18 over 2. The coordinates we get is -7, 9. These are the coordinates of the center O. Now the second thing which they are asking us to find is the radius of C. So the radius, if you are considering, it is OQ or OP. These both are radiuses. So let me take the radius OQ. So let me take R as OQ. And to find the radius, we are going to use the distance formula. Distance formula is given as square root of x minus x2 the whole square plus y minus y2 the whole square. Since I have taken OQ, coordinates are xy and Q's coordinates are x2 and y2. That's why I have written it as x minus x2 and y minus y2. Suppose if you are using OP, then it would have changed as x minus x1 the whole square plus y minus yn the whole square. It totally depends on which side you are going to take for the radius. Both the sides will give you the same answer, same radius. So let us just substitute the values. X we have it as -7 and x2 we have as negative of -3. Now let us square it, whole square, plus y is 9 minus y2 is 12, the whole square. So let us just simplify it a little bit. So we get it as -7 and negative of negative is positive. So negative 7 and positive 3 gives you negative 4 the whole square plus 9 minus 12 is minus 3 the whole square. So it becomes square root of negative 4 square is 16 and negative 3 square is 9. So you have square root of 25. The square root of 25 is 5. So we got the radius as 5. So this is the answer for the center of the circle, negative 7, 9. And this is the answer for the second part of the question. This is the second part of part 2. Radius. So radius is 5. Now let us look at the B part of the question. It is saying, let's find an equation of C. So C is a circle. We need to know the equation of the circle. And we just found out the center of the circle is negative 7, 9. So we have equation of the circle given as equation of circle whose center is A, B and radius is R. It is given as x minus A the whole square plus y minus B the whole square equal to R square. A and B are the center of the circle. Now, the center of the circle and the radius we have just got. O was given as, so we have found it as negative 7, 9. It was negative 7, 9. And radius we had got it as 5 over here. So let us just substitute in this equation to get x minus of minus 7 the whole square plus y minus 9 the whole square equals 5 square. Further simplifying it, we get x plus 7 the whole square plus y minus 9 the whole square equals 25. This is the equation of the circle C. If you want, you can further expand this equation, these brackets, you can expand it and then you can simplify it also. So both formats will be accepted. Either you write it this way or you go further few steps by expanding these brackets and simplifying it. Both answers are acceptable. Now let us look at the C part of the question. Find an equation of tangent to C at the point Q, giving your answer in the form ax plus by plus c equal to 0, where a, b and c are the integers to be found. So it is the same circle which we had drawn, which was having the diameter Q. Now here I'll be taking only the center we had got O, and I'll be taking the point Q. The center we had got the coordinates are as negative 7, 9, and the coordinates of Q were negative 3, 12. What are they asking is, find an equation of the tangent to C at the point Q. That means there is a tangent running exactly to point Q. So we need to find out the equation of this tangent. To find the equation of the tangent, I am going to make use of the radius. So Q was the radius. So somehow if I find out the slope or gradient of the radius, I can find out the slope of the tangent, because these two are perpendicular always to each other. The radius is always perpendicular to the tangent. So let me find out the slope of the radius first. So slope of radius or gradient of radius is given as y2 minus y1 over x2 this is the general formula which we use. Here we are going to use the coordinates of O and Q. Phi 2 I'll be taking it as 12 minus phi 1 is 9 and x2 is negative 3, negative of negative 7. So we get it as 3 over negative 3, negative of negative is positive 7. So negative 3 and positive 7 will be 4. Now this is the gradient of the radius. Now tangent is always perpendicular to the radius. So when the two lines are perpendicular, we usually write the formula as slope of gradient of radius times gradient of tangent equals negative 1. This is the formula we always use when the lines are perpendicular. Now since they are asking us to find equation of tangent, we need the gradient of tangent. Therefore, this gradient of radius was 3 over 4 times the gradient of tangent equals negative 1. So we get the gradient of tangent as negative 1 times 4 over 3. Or we can write it as just negative 4 over 3. Now, to find the equation of the tangent at point Q, we have the formula. Let me write it. Equation of tangent. Written as y minus y1 equals m of tangent x minus x1. This is the general formula which we use. So y minus y1 and x1 are the Q points. So here y1 is 12. So let me write here as 12 equals m tangent, we got it as negative 4 over 3 and x minus x1 was negative 3. So minus of minuses was 3. Now I will be taking the 3 over this side. So it multiplies with y minus 12. This becomes negative 4 x minus x plus 3. It becomes 3y minus 3 times 12 is 56 equals negative 4x and negative 12. So bringing these two terms on the side, we get plus 4x plus 3y minus 36 and plus 4. Finally, we get the answer as 4x plus 3y and minus 36 and plus 12 is minus 24 equal to 0. So this is the answer, and they had expected us to write in this form ax plus by plus c equal to 0. So this is ax plus by plus c equal to 0. But a is 4, b is 3 and c is negative 24. Let it be. So here it is. This is what we have got the answer for the final part of this question.